I'm Jacob Blair. Today I'm going to be talking to you about a problem that we're facing that I think is very important. If you've ever gotten a bacterial infection like this one, you may have been prescribed antibiotics in order to treat it. Antibiotics are great tools that kill the bacteria within the body, and they've dominated medical treatment of bacterial infections since they've been introduced. To this day, they've saved thousands of lives and continue to do so every day. But there is a problem with antibiotics, and it's a big one. Bacteria are evolving. Random mutations can allow a small amount of bacteria to survive an antibiotic attack, and those bacteria reproduce to increase the amount of antibiotic-resistant bacteria. Eventually, traditional antibiotics become no longer effective against certain diseases. Bacteria that can resist antibiotics and aren't affected by them are known as superbugs. There's an increasing amount of superbugs that occur each year, and it's becoming a big problem. It's estimated that at least 2 million Americans were affected by some kind of antibiotic-resistant bacteria in 2017. And it's also estimated that 23,000 of those Americans died as a result of some kind of effect from their superbugs. The problem is only going to get much worse, and it's predicted that by 2050, 10 million deaths could be attributed to superbugs. So what's the solution? What can we do? Well, I'm going to be presenting an interesting idea to you about using something that you might not expect, viruses. Specifically, bacteriophages. A bacteriophage is a virus that infects bacteria, to put it simply. It does not target humans. It's specifically designed, well, it's evolved in order to target certain strains of bacteria. The interesting thing about bacteriophages is that there are more bacteriophages than any other living thing on Earth, including bacteria. What this means is that they're everywhere. You know, like they're all around us, just like bacteria or microbes are. They're in that same vein. So I'll show you a diagram of the bacteriophage right here. As you can see, it looks like a typical virus. It has DNA, nucleic acid, and then the rest of it is made up of a protein coat, and it also has a protein tail. Now, the interesting thing about a bacteriophage's tail is that it is extremely specific. It can only target very specific strains of bacteria. And what this means, and why I think it's really interesting and important, is that bacteriophages are very targeted, and there's very little risk. For instance, like you might think, why do I want to even worry about using viruses? But bacteriophages do not affect us at all because they only have the ability to target very specific types of bacteria. So basically what it means is that bacteriophage receptors, they can't attach to our cells or even like another type of bacteria that's just a little bit different. They can't even attach to that kind. They're only very specifically designed for a few different kinds of one type of bacteria. It is true, since bacteria evolve as well, it makes sense that they would evolve in order to protect themselves from bacteriophages. But bacteriophages have proven to be very effective, and they evolve with the bacteria in what you might call an evolutionary arms race. So you might think that this is all very interesting and be wondering, why haven't we looked into this as much? And the truth is, we've started to, but we've been held up by a lot of things. First of all, bacteriophages were actually discovered before antibiotics. They were discovered in 1917. And once antibiotics were discovered, it became like bacteriophages weren't as interesting to people because they saw antibiotics as a much easier and more effective way of treating bacterial infections. And at the time, it certainly was. The research just wasn't out there with bacteriophages. We didn't know enough about how effective they would be. So antibiotics were much more effective than bacteriophages at the time. But obviously, it didn't age very well because now we're starting to have problems with superbugs. So another problem with bacteriophage research is what little research did get done was often extremely flawed. One of the main problems was that early research didn't use a control group because basically the people who were still trying to study bacteriophages were using it as a last-ditch effort to save someone's life. They weren't really setting up a fair experiment with controls or anything like that. And then another big problem was that they just didn't have the technology to utilize bacteriophages to their full potential. They didn't have the ability to separate out bacteriophages by specific strains as well as we can today, and they also didn't have the technology to basically avoid contamination. A lot of times the experiments that they did do, it's likely that the bacteriophages that they tried to use were contaminated with some other substance that skewed the results. So that's why many early experiments failed, and that's also why bacteriophages sort of dropped off the map and stopped being used. Now, there is a future of phage therapy, especially with the rise of superbugs. People are starting to realize that bacteriophages may have some kind of use, and so that's beginning to lead to some new developments. But what I'm here to argue is that it's something that everyone should be worried about, and we need to invest in it much more heavily than we are at the moment. So why should we do this? First of all, we have the technology now to do real cutting-edge research on bacteriophages that we couldn't do before. We don't know enough about bacteriophages, and that's probably one of the big reasons that bacteriophage therapy hasn't had much success. Phage therapy can't be widespread at the moment because it requires a very special approval from the FDA to use it in human trials, and the reason is because there just hasn't been enough research done on bacteriophages to determine whether anything about it is harmful. So what I'm arguing here is that we have the new technology that can allow us to identify specific strands of bacteriophages, figure out what those bacteriophages target, figure out like the exact kind of research we need to do. And I think if we use new laboratory techniques combined with old knowledge, then we can learn a lot about bacteriophages and about the possibility of phage therapy being used. And phage therapy basically just means using bacteriophages as medicine or to treat something. Phage therapy is obviously going to be much more necessary as time goes on because of the superbug threat. And I believe that we can get the research done, we can build a basis for using it as medicine with the new modern techniques that we have now. So what do we think needs to be done? First of all, I think we need much more testing. We need many clinical trials to start happening, more research done on bacteriophages, better techniques to like separate and identify bacteriophages. And I think pharmaceutical companies should really start looking into bacteriophage therapy because the superbug problem is going to get worse and we need an answer to it very quickly. And obviously the fastest way to do that is with the backing of major companies. And I also think it would be beneficial for them as well as everyone. We need to find more information about how bacteria evolved to fight phages. That way we can make sure something like with antibiotics where bacteria becoming resistant to them, the same thing doesn't necessarily happen with phages. And I think there's less of a chance of that happening because phages can evolve along with bacteria, but I still think we need more research on it. And then I truly believe that bacteriophages are the future and that they're our best bet against the threat of antibiotics failing. I do think that we need to be careful. Oftentimes we might misinterpret something or make a mistake and think that, oh, bacteriophages are the solution, and we just kind of overuse them, sort of like we did with antibiotics. And I think now that we have the lessons that we've learned from overuse of antibiotics, we can take that information and be much more careful about testing and using bacteriophages. So, in conclusion, we need more research on bacteriophages, and I think once we get that research done, we can actually start looking into more clinical trials and more use of bacteriophages as medicine. And maybe there's a possibility that it could be the answer to the problem of superbugs. Thank you for watching.